Hey physics friends, Mr. Collier here. We've got another sample momentum problem. Here we're going to look at something slightly different and talk about how momentum relates to forces. So we have a car accident where a 1,000-kilogram car goes from 30 miles per hour to 0 miles per hour. And a little reminder, 1 mile per hour is equal to 0.447 meters per second. So what we're going to do is I've broken this problem down into kind of parts. We're going to figure out what the initial and final momentum are so that we can figure out how much its momentum changes, and then we're going to use that to figure out the force acting on it. So in A, all we need is the initial momentum, which is just the mass times the initial velocity, right? And the mass of the car is 1,000 kilograms, and we're going to multiply that by the velocity, which is 30 miles per hour, but we do need to convert that, and we know that 1 mile per hour is equal to 0.447 meters per second. And when you do all that, you'll get the initial momentum of, I believe it's 13,410. We're not worrying about sig figs right now. So that's the initial momentum. So it's got a lot of momentum because it's a fairly large object going at a decent speed. For B, we're looking at the final momentum, and that's just as simple as mass times final velocity, and the final velocity is 0. So the final momentum is 0 kgms. And then in C, and this is where we got to use a new equation here, we're going to talk about the average force. So the average force is equal to the change in momentum over time. Okay, I derived this in your notes from this chapter, right? And what this is going to tell us is how much did the momentum change divided by how long did it take to change. And you're going to see something nice here is that the units actually work out. So the change in momentum would be the final minus the initial momentum. We're going to divide that by the time. So the final momentum is 0. The initial momentum is 13,410 kgms. And we're going to divide that by the 0.75 seconds it takes for this change in momentum to occur. That's going to give us 17,880 kgms. Oh, I'm sorry, it's negative. That's important. And I'm sorry, those units are not kgms. Those units are, this was the thing I wanted to talk about, they're kgms over s. So they're kilograms times meters per second per second. Oh, hey, that is a mass times an acceleration, which are the units for force. So all of that becomes newtons, which is exactly what we're looking for. So negative 17,880 newtons. So a unit of force pops out of this, and also it is negative, indicating that this force is in the opposite direction of the initial velocity, which makes sense. How do you stop an object? You apply a force in the opposite direction that it's moving. So that's it for that one. Let me know if you have any questions.